Imagine standing at the base of the Great Pyramid of Giza, craning your neck to take in its towering presence 4,500 years after it was built. This colossal structure, made of 2.3 million stone blocks, each weighing as much as a small car, was assembled with such precision that you can't even slide a credit card between them. And here's the kicker: we still don't fully understand how the ancient Egyptians pulled it off without modern tools or machinery. That's the kind of mystery we're diving into today. Ancient engineering feats so advanced, so ingenious, they defy logic even now. From the towering pyramids to underground cities carved into solid rock, our ancestors achieved what should have been impossible with the technology of their time. These weren't just random projects, they were monumental displays of human creativity, patience, and sheer brilliance. Think about it. How did the Romans build concrete that lasts longer than anything we make today? How did a civilization without satellites align structures perfectly with the stars? These aren't just historical footnotes, they're puzzles that keep scientists and engineers awake at night, scratching their heads in awe. That's why we're about to embark on a journey through 30 of the most jaw-dropping ancient engineering marvels ever created. We'll uncover the secrets behind megalithic monuments, ingenious water systems, and structures so durable they've outlasted empires. Along the way, you'll discover how these achievements weren't just about brute strength. They were about problem solving on a scale that still inspires us today. So if you've ever wondered how the impossible became possible, or if you just love a good mystery, you're in the right place. Get ready to have your mind blown by the sheer ingenuity of the ancient world. The Great Pyramid of Giza isn't just big, it's terrifyingly precise. Every side of this 4,500-year-old marvel aligns almost perfectly with the cardinal directions, deviating from true north by less than a fraction of a degree. That's an accuracy level modern engineers would struggle to achieve without satellite technology. Yet the ancient Egyptians pulled it off using nothing but the stars, simple tools, and sheer ingenuity. And that's just the beginning. Take the blocks themselves, each weighing as much as 2.5 tons, with some reaching a staggering 80 tons. How did they move these mammoth stones across miles of desert without wheels or iron tools? One theory suggests they built massive ramps, zigzagging up the pyramid's sides as it rose, hauling stones on sledges lubricated with water to reduce friction. Another idea points to intricate systems of canals, using the Nile's annual floods to float blocks closer to the site. Then there's the wilder speculation. Could they have had access to some lost technology or forgotten methods we haven't even considered? What's undeniable is the craftsmanship. The stones fit together so tightly that not even a razor blade can slip between them, and this precision wasn't just for show. It's part of why the pyramid has stood for millennia, resisting earthquakes and erosion. Modern concrete cracks within decades, but the pyramid's core remains untouched, a testament to an understanding of materials we're still trying to decode. And here's the kicker: they did all this without blueprints, without cranes, without any of the tools we take for granted today. It forces us to ask, what else did they know that we've forgotten? Theories will keep evolving, but one thing's clear: the Great Pyramid wasn't just a tomb. It was a statement, a challenge carved in stone, daring us to unravel its secrets. And even with all our modern knowledge, we're still catching up to what they achieved over 4,000 years ago. Buried beneath the Mediterranean waves for over 2,000 years, the Antikythera Mechanism is proof that ancient technology wasn't just about brute strength, it was about brain power. Discovered in a shipwreck off the coast of Greece in 1901, this baffling bronze device, no larger than a shoebox, contained a labyrinth of interlocking gears so precise it could predict celestial events decades in advance. Think about that for a second. This wasn't just a calendar or a simple tool. It was a mechanical computer, centuries ahead of anything else from its time, capable of tracking the movements of the sun, moon, and planets with astonishing accuracy. The real genius lies in its engineering. Tiny, hand-cut gears, some with as many as 223 teeth, meshed together to simulate the erratic orbits of celestial bodies. It even accounted for irregularities like the moon's wobbling path, a detail so advanced that comparable technology wouldn't reappear until the 14th century in Europe. And here's what's truly wild. Scientists using modern X-ray imaging found inscriptions on the device's panels that essentially served as an instruction manual, explaining how to read its predictions like an ancient user's guide to the cosmos. But the biggest mystery isn't how it worked, it's why we've never found anything else like it. Was this a one-of-a-kind marvel crafted by a lone genius whose knowledge died with them? Or was it part of a wider tradition of Greek mechanical engineering, lost to time because bronze was so often melted down and reused? Some historians point to cryptic references in ancient texts like Cicero's mention of a similar device built by Archimedes, suggesting this might have been just one star in a constellation of forgotten inventions. What's undeniable is that the Antikythera Mechanism shatters our assumptions about technological progress. It forces us to wonder how much knowledge vanished when libraries burned or empires fell. And if this single artifact survived purely by chance, what other breathtaking creations slipped through the cracks of history, leaving no trace behind? The Romans built to last nowhere. Is this more obvious than in their concrete? 2,000 years later, their harbors still stand strong underwater, while modern concrete bridges and sidewalks crumble after just a few decades. The secret, a recipe so effective we're still trying to crack it. Their concrete wasn't just durable, it actually got stronger over time, thanks to one surprising ingredient: volcanic ash. Unlike today's mixes, which rely heavily on Portland cement, Roman concrete incorporated ash from eruptions near the Bay of Naples, creating a chemical reaction that filled cracks as they formed. It's like the material had a built-in repair system, healing itself when exposed to seawater. Marine structures that should have disintegrated centuries ago remain intact, almost mocking our modern attempts to match their longevity. How did this revolutionary knowledge vanish? Part of the answer lies in the fall of Rome itself. As the empire collapsed, so did the intricate trade networks supplying volcanic ash from specific regions. Without access to these key materials, later builders improvised with inferior substitutes, and the original recipe faded into obscurity. Even written records from the time, like those by the architect Vitruvius, only offered vague descriptions, enough to hint at the process but not enough to truly replicate it. For centuries, historians assumed concrete was a modern invention until those ancient piers and aqueducts forced us to reconsider. Today, scientists are racing to reverse engineer Roman concrete, analyzing samples under electron microscopes to uncover its molecular secrets. They've discovered tiny, crystalline structures within the volcanic ash mix that prevent corrosion, a feature modern materials lack. Some researchers are even experimenting with adding volcanic rock to contemporary cement, hoping to create a hybrid that combines ancient wisdom with today's technology. The irony is thick. We're spending millions to relearn what the Romans already knew, a lesson in humility wrapped in 2,000-year-old stone. What's fascinating is that the Romans likely didn't fully understand the chemistry behind their own miracle material. They simply knew it worked, refining their methods through trial and error. It's a reminder that sometimes the greatest engineering feats aren't about having all the answers, but about persistence, observation, and a willingness to learn from the environment. And that's the real challenge they've left us, not just to rebuild their concrete, but to recover their mindset, one where durability wasn't an afterthought, but the very foundation of civilization. Stretching across the arid plains of southern Peru, the Nazca lines are one of archaeology's most bewildering puzzles. Enormous drawings etched into the desert floor so large they can only be fully appreciated from the sky. Some stretch over 600 feet long, depicting spiders, hummingbirds, monkeys, and geometric shapes with such crisp precision, it's hard to believe they were crafted over 2,000 years ago by people who supposedly never left the ground. How did the Nazca culture achieve this staggering accuracy without the ability to fly? The answer lies in a mix of simple tools, mathematical ingenuity, and an intimate knowledge of their environment. Archaeologists believe the Nazca used ropes, wooden stakes, and careful measurements to plot out each design, scaling up smaller models etched into the ground. By creating a series of guide points and connecting them with straight lines, they could replicate complex shapes across vast distances. The desert's stable climate played a crucial role. Thin, dark surface rocks were removed to reveal lighter soil beneath, creating contrast, while the lack of rain and wind preserved the lines for centuries. But here's the real kicker. The Nazca might have used natural vantage points like nearby hills to oversee portions of their work, proving you don't need an airplane when you have patience and planning. The purpose of these geoglyphs is even more hotly debated. Some researchers argue they were astronomical markers, aligning with solstices or constellations to track planting cycles. Others suggest they were sacred pathways, walked during rituals to invoke water from the gods, a precious resource in one of the driest places on Earth. Then there are the wilder theories, like extraterrestrial landing strips or messages to deities in the sky. While the alien runway idea makes for great storytelling, there's no concrete evidence to support it. What we do know is that the Nazca lines weren't meant to be seen by humans daily. They were a spiritual offering, a giant canvas meant for the heavens. What's truly remarkable is how these fragile lines have endured. Unlike stone monuments, they're just shallow grooves in the earth, vulnerable to even minor disturbances. Yet, thanks to the region's unique microclimate where it almost never rains and winds are gentle, they've outlasted empires. Modern threats like foot traffic and climate change now endanger them, making their preservation a race against time. Standing amidst these ancient drawings, you're left with one overwhelming thought. The Nazca didn't just leave behind art. They left behind a riddle, one that challenges our assumptions about ancient technology and human creativity. And perhaps that was the point all along, to make us look up, wonder, and keep searching for answers. The Hanging Gardens of Babylon have captivated imaginations for centuries, often described as a lush, terraced paradise rising above the arid Mesopotamian desert. But here's the twist. There's no solid archaeological evidence they ever existed in Babylon. Ancient texts like those of Greek historians Strabo and Diodorus Siculus paint vivid pictures of towering greenery watered by advanced irrigation, yet not a single Babylonian record mentions them. This glaring absence has led some scholars to propose a radical theory. The gardens weren't in Babylon at all, but in Nineveh, the Assyrian capital, built by King Sennacherib 200 years earlier. If the gardens were real, their engineering would have been revolutionary. Imagine a series of tiered platforms, each bursting with trees, vines, and exotic plants, all fed by a complex system of screws, pumps, and aqueducts channeling water from the Euphrates River. One account describes a chain pump, a loop of buckets lifting water to the highest tier, where it cascaded down through channels to nourish every level. For a desert city, this wouldn't just be a display of wealth, it would be a defiance of nature itself. The logistics are mind-boggling: soil deep enough for tree roots to anchor, constant maintenance to prevent evaporation, and a workforce skilled enough to keep it all running. The Nineveh theory gains traction from Sennacherib's own inscriptions, which boast of an unrivaled palace with a garden that replicates mountains, complete with bronze screws to lift water. Archaeologists have even found remnants of an elaborate aqueduct system near Nineveh that matches these descriptions, yet the myth persists, tied to Babylon's legendary status. Whether a case of mistaken identity or pure legend, the Hanging Gardens challenge our understanding of ancient innovation. They force us to ask, does it matter if they were real, or is their power rooted in what they represent, humanity's timeless urge to create the impossible? Deep beneath the soil of central China lies an army frozen in time, 8,000 terracotta warriors, each with a unique face, standing guard for over 2,000 years. Discovered by farmers digging a well in 1974, the Qin dynasty's Terracotta Army is more than just a collection of statues. It's a snapshot of ancient ambition on an unimaginable scale. Every soldier, archer, and cavalryman was crafted life-sized, with intricate details like individually braided hair, textured armor plates, and even realistic footwear treads. But here's what's truly staggering. This wasn't art for art's sake. It was a military formation organized into precise ranks, ready for battle in the afterlife. The production behind this army reveals a level of industrial efficiency that rivals modern factories. Archaeologists found evidence of an assembly line system where different workshops specialized in specific body parts, heads, torsos, limbs, all standardized for mass production but customized later with unique facial features and expressions. This wasn't just craftsmanship, it was logistics perfected centuries before the Industrial Revolution. Even the kilns used to fire the figures were strategically placed near the excavation site to minimize transport, showing a mastery of supply chain management that feels eerily contemporary. Yet the biggest mystery lies just beyond the army's ranks, the untouched tomb of Emperor Qin Shi Huang himself. Ancient texts describe a subterranean palace with ceilings mimicking the night sky, set with pearls as stars and rivers of flowing mercury representing China's great waterways. Modern surveys have detected unusually high mercury levels in the soil above the tomb, lending eerie credibility to these legends. But why hasn't it been opened? The answer is equal parts caution and reverence. Experts fear exposing the tomb could damage irreplaceable artifacts, silks, writings. Even the emperor's remains preserved for millennia in controlled conditions. There's also the lingering question of booby traps hinted at in historical accounts, designed to protect the emperor's rest for eternity. What makes the Terracotta Army so compelling isn't just its scale or craftsmanship, it's what it represents. Qin Shi Huang didn't just want to rule in life, he sought to conquer death itself, surrounding himself with an eternal guard to secure his power in the next world. In doing so, he left behind a testament to human ingenuity and a reminder that some secrets, even after 2,000 years, aren't ready to be uncovered. Deep beneath the rocky landscape of Cappadocia, Turkey, lies a labyrinth so vast it could hide an entire civilization, the ancient underground city of Derinkuyu. Carved straight into volcanic rock over 2,000 years ago, this wasn't just a temporary refuge, it was a fully functional metropolis designed to shelter up to 20,000 people for months at a time. Picture this, 18 levels descending nearly 300 feet underground, complete with living quarters, stables, churches, wineries, and even a rudimentary school system. But what's truly astonishing isn't just its scale, it's how every detail was engineered for survival against threats from above. The city's architects tackled challenges modern engineers would struggle with. Ventilation shafts, some stretching over 100 feet upward, provided fresh air to even the deepest chambers without revealing their location to outsiders. Ingenious water wells tapped into underground aquifers, ensuring a steady supply while preventing contamination from surface enemies. And then there were the doors, massive rolling stone discs, each weighing up to half a ton, could seal off entire sections in seconds. These weren't just barriers, they were strategic choke points designed to funnel invaders into narrow corridors where defenders could pick them off one by one. But why go to such extremes? The answer lies in Cappadocia's turbulent history. Sandwiched between warring empires, the region's inhabitants faced constant threats from Persian armies, Arab raiders, and later Mongol hordes. Derinkuyu wasn't unique. Over 200 underground cities dot the area, many connected by miles of hidden tunnels, but its sophistication sets it apart. Archaeologists have found evidence of communal kitchens with smoke channels disguised as natural fissures, livestock pens on lower levels to mask sounds, and even designated areas for pressing grapes, suggesting life underground wasn't just about survival. It was about preserving normalcy during prolonged sieges. The real mystery isn't how they built it, but how they kept it secret. Unlike grand pyramids or temples, Derinkuyu left no visible trace on the surface. Entrances were camouflaged as ordinary wells or tucked inside innocent-looking homes, a lesson in stealth engineering that modern militaries still study. Today, only about 10% of the city is accessible to visitors. The rest remains unexplored, leaving us to wonder what other innovations or secrets might lie in the darkness. Standing in those torch-lit tunnels, you can't help but feel the weight of history pressing in, a reminder that sometimes the greatest feats of engineering aren't the ones that reach for the sky, but those that vanish beneath our feet. High above the city of Cusco, the massive stone walls of Sacsayhuaman stand as a silent challenge to modern engineering. These aren't just rocks stacked together, they're polygons weighing up to 200 tons, carved and fitted so precisely that even today, you can't slip a piece of paper between them. And here's the twist: the Incas built this fortress in the 15th century without iron tools, mortar, or even the wheel. So how did they pull it off? Theories range from the plausible to the downright fantastical, each more fascinating than the last. Start with the basics. The Incas had an intimate knowledge of stone, selecting dense andesite blocks from quarries miles away. Using harder stones like quartzite as tools, they likely pounded and ground the surfaces into shape through sheer patience and brute force, but precision. That's where things get wild. Some researchers suggest they used a method called guess and check, repeatedly lifting and lowering stones to test the fit, gradually shaving off imperfections until the fit was seamless. Others propose they soften the rock with plant acids or heat, allowing for easier shaping, a technique that might explain why some surfaces appear slightly melted. Then there are the fringe theories. Could the Incas have harnessed sound or vibration to levitate these massive blocks into place? Ancient legends speak of priests using magical frequencies to move stone, and modern experiments with acoustic levitation show it's not entirely impossible, just wildly impractical on this scale. Another idea points to lost metal alloys or even advanced tools made from materials we haven't rediscovered yet, though no physical evidence supports this. What's undeniable is the result. These walls have withstood centuries of earthquakes that flattened Spanish colonial buildings around them. The zigzag design isn't just for show, it disperses seismic energy, proving the Incas understood structural integrity in ways we're still unpacking. Standing before these stones, you're left with a humbling thought. Maybe we've underestimated just how ingenious ancient builders really were. Their methods might remain a mystery, but their legacy is set in stone, literally. Standing in the heart of Delhi, a 23-foot iron pillar has baffled scientists and historians for centuries. Built in the 4th century, this ancient marvel has endured monsoons, scorching heat, and pollution without a trace of rust, an impossibility by modern metallurgical standards. The secret, a forgotten alloy recipe so advanced it predates corrosion-resistant steel by over a millennium. What makes this pillar extraordinary isn't just its age, but the precision of its craftsmanship. Analysis reveals a high phosphorus content, nearly 1% mixed with iron, in a way that creates a thin, protective film on the surface. This layer shields the metal from oxygen and moisture, effectively stopping rust before it can start. Modern metallurgists didn't grasp this principle until the 20th century, yet ancient Indian blacksmiths perfected it through trial and error, likely using a unique furnace technique to control the alloy's composition. But here's the twist: the same phosphorus that prevents rust would typically make iron brittle and prone to cracking. Somehow, these artisans found the perfect balance, crafting a pillar that's both durable and flexible enough to withstand earthquakes and centuries of wear. Even more puzzling, the inscriptions on the pillar commemorating a king's victories remain crisp and legible, proof that the metal hasn't degraded or warped over 1600 years. How did this knowledge vanish? Unlike Rome's concrete or Greek gears, this technology didn't spread beyond India. Some historians suggest the recipe was a closely guarded secret of certain guilds, lost when those traditions faded. Others point to the decline of large-scale ironworking in the region as later empires shifted focus to other materials. Today, scientists are racing to decode the pillar's composition, hoping to adapt its rust-proof properties for modern infrastructure, bridges, pipelines, even spacecraft. Standing before it, you're faced with a humbling reality. Our ancestors didn't just work metal. They mastered it on a molecular level, achieving feats we're still struggling to replicate. The pillar isn't just a relic, it's a silent challenge daring us to uncover the brilliance hidden in plain sight. Perched in Lebanon's Bekaa Valley, the ruins of Baalbek hide a mystery that defies even our modern understanding of engineering. The trilithon, 3 stone blocks each weighing a staggering 800 tons. To put that in perspective, that's heavier than 2 fully loaded Boeing 747 jets. And these aren't just crude slabs, they're precision-cut monoliths fitted seamlessly into the base of a Roman temple complex, lifted 20 feet off the ground like some ancient Lego set for giants. The question isn't just how the Romans moved them, it's how anyone could have moved them without the technology we assume was absent 2,000 years ago. One theory points to human ingenuity on a colossal scale. Historians suggest the Romans might have used a system of wooden sledges, ropes, and capstans. Think of a giant spool winding cables powered by hundreds of laborers or even oxen. They could have built temporary earthen ramps to drag the stones into place, then dismantled the ramps afterward. But here's the catch: even with these methods, the margin for error is razor thin. One wrong tug, one snapped rope, and the block could have crushed workers or shattered irreparably. The logistics alone, feeding and housing an army of laborers, maintaining equipment, would have been a feat rivaling the construction itself. Then there are the wilder ideas. Some researchers point to ancient accounts of sound levitation, where vibrations or harmonic frequencies allegedly made stones lighter. While it sounds like science fiction, experiments with acoustic standing waves have shown tiny objects can be suspended in midair. Could an advanced civilization have scaled this up? Others speculate about lost machinery like massive cranes or counterweight systems, though no physical evidence survives. And let's not forget the local legends, tales of a long-vanished race of giants who built Baalbek, whispered in Lebanese folklore for centuries. What's often overlooked is the quarry itself, located nearly a mile away. There, an even larger block, the Stone of the Pregnant Woman, lies abandoned, weighing an estimated 1,200 tons. Chisel marks still visible on its side suggest it was being prepared for transport when something went wrong. Was it too ambitious even for Baalbek's builders? Or did they abandon it because their secret technique failed? The Romans left no blueprints, no manuals, just these silent, monstrous stones, daring us to unravel their secrets. Standing before the trilithon, you're faced with an unsettling possibility. Maybe we've underestimated the technological prowess of the ancient world. These blocks weren't just stacked, they were placed with surgical precision, defying erosion and earthquakes for millennia. Whether through brute force, forgotten physics, or something we haven't yet imagined, Baalbek stands as a humbling reminder. Some ancient achievements don't just defy logic, they mock it. On a remote island in the Pacific, nearly 900 massive stone statues stand guard over an ancient mystery. How did the Rapa Nui people carve and transport these colossal figures without metal tools or beasts of burden? The Moai of Easter Island, some towering over 30 feet tall and weighing more than 80 tons, weren't just sculpted with primitive basalt picks. They were moved miles across rugged terrain to their ceremonial platforms. For decades, theories ranged from the plausible to the absurd: alien intervention, lost technologies, even giant levitating logs, until a breakthrough experiment revealed a shockingly simple yet brilliant solution: the statues might have walked. Archaeologists Terry Hunt and Carl Lipo proposed a radical idea in 2012. What if the Rapa Nui didn't drag the moai horizontally, but rocked them upright using ropes, making them walk like a wobbly refrigerator? Their team tested the theory with a scale model, showing how just 18 people with 3 sturdy ropes could pivot a multi-ton statue forward in a rhythmic swaying motion. The key was the statue's design. Their center of mass and curved bases allowed them to tilt and shift with each controlled pull, leaving telltale marks on the island's roads that match this movement. Gone were the myths of endless log rollers or supernatural help. This was pure physics and human coordination, but the story doesn't end there. Recent 3D scans of the island's roads revealed something even more fascinating. The paths aren't flat but slightly concave, with raised shoulders that would have naturally stabilized the statues during transport. This wasn't just trial and error, it was engineered efficiency, a testament to the Rapa Nui's intimate understanding of balance and terrain. And let's not forget the carving itself. Each moai was chiseled from compressed volcanic ash at Rono Roroku Quarry, where half-finished statues still lie embedded in the rock. The process was meticulous, with artisans shaping faces and torsos using nothing but stone tools, then undercutting the figures to free them from the cliffside. What's most striking isn't just the how, but the why. These weren't idle projects. The moai represented ancestors, their backs turned to the sea to watch over villages, embodying a spiritual connection to the land. The effort required thousands of hours per statue, communal labor, and risky transport speaks to a society deeply invested in collective purpose. Yet the narrative of Easter Island as a cautionary tale of ecological collapse is being rewritten too. New evidence suggests the Rapa Nui didn't recklessly deforest their island to move statues. They adapted, innovated, and thrived far longer than previously thought. Standing before a moai today, you're not just looking at a relic of the past, you're witnessing a masterclass in problem solving, a reminder that human ingenuity doesn't always need advanced technology. Sometimes it just needs creativity, patience, and a few good ropes. And that's the real lesson of Easter Island. The answers to ancient mysteries are often simpler than we imagine, hidden not in lost civilizations or alien hands, but in the cleverness of ordinary people doing extraordinary things. Hidden beneath the lush hills of Zhejiang province in China, the Longyu caves defy logic, not just for their sheer scale, but for their eerie precision. Discovered by accident in 1992 when a curious villager drained a local pond, these 24 hand-carved caverns stretch across 30,000 square meters, each one a masterpiece of underground engineering. The walls, ceilings, and towering pillars are cut with such geometric perfection that they look machined, yet every groove was painstakingly chiseled by human hands over 2,000 years ago. But here's what really stops archaeologists in their tracks. Not a single historical record, scroll, or local legend mentions their construction. It's as if the workers vanished, taking their secrets with them. Step inside one of these caves, and the first thing you'll notice is the acoustics. The walls are angled in a way that amplifies even a whisper, suggesting these spaces weren't just quarries or storage pits, they were designed with sound in mind. Some researchers theorize they were used for rituals, their resonance chambers creating an otherworldly atmosphere during ceremonies. Others point to the intricate patterns of parallel chisel marks covering every surface, suggesting a symbolic meaning lost to time. Then there's the sheer labor involved. Estimates suggest removing over 1 million cubic feet of stone would have required 1,000 workers laboring non-stop for 6 years. Where did they put all that rubble? No debris field has ever been found, adding another layer to the mystery. Theories about the cave's purpose range from the practical to the fantastical. Could they have been secret bunkers for an emperor's army, hiding troops from invaders? The uniformity of the chambers supports this, each nearly identical in size and shape, like barracks carved from solid rock. There's also the astronomical angle. Certain pillars align with star patterns visible 2 millennia ago, hinting at a celestial calendar function, but the most haunting idea, that they're the work of a now-forgotten dynasty, erased from history by rivals or natural disasters. Without inscriptions or artifacts, we're left with only the caves themselves as clues, their silence louder than any written record. What makes the Longyou sins truly unsettling isn't just their precision or scale. It's the complete absence of context. Most ancient sites come with hints, pottery shards, burial goods, even graffiti. Here, there's nothing but bare stone and unanswered questions. Modern attempts to replicate the cave's construction using traditional tools have failed to match their efficiency, suggesting techniques we've yet to rediscover. Standing in their shadowy depths, you can't help but feel the weight of that mystery, an entire chapter of human ingenuity, carved in stone and then deliberately or catastrophically forgotten. Teotihuacan's sprawling grid, laid out over 15 square miles nearly 2,000 years ago, isn't just an urban marvel, it's a celestial map etched into the earth. Walk down the Avenue of the Dead today, and you're tracing a path deliberately aligned with the Pleiades star cluster, a formation sacred to cultures across the Americas. When those stars reached their zenith each year, the entire city would have pulsed with ritual significance, its temples and plazas transforming into a mirror of the heavens. But the real shock isn't just the alignment, it's the precision. Modern surveys reveal the city's main axis deviates from true north by just 15.5 degrees, matching the Pleiades' position around the time of its founding. This wasn't guesswork, it was astronomy encoded in stone. Then there's the Pyramid of the Sun, Teotihuacan's crown jewel. Beneath its massive limestone facade lies a secret that still puzzles engineers: thick layers of mica, a mineral prized today for its ability to insulate electrical currents. Discovered in the 1900s, these sheets were deliberately sandwiched between construction levels, some transported from mines over 2,000 miles away in Brazil. Why go to such lengths? Mica's heat-resistant properties could theoretically protect sensitive structures, leading some to speculate about lost energy applications. More grounded theories suggest ritual symbolism. Mica's glittering surface might have represented the sun's brilliance or served as a spiritual barrier. But the absence of written records leaves us with a tantalizing void. Was this advanced material science or sacred geometry? Look closer at the city's water systems and the mystery deepens. Beneath the streets, intricate channels follow the same celestial alignments, suggesting hydraulic engineering intertwined with cosmology. Even the placement of smaller pyramids creates acoustic effects. Whispers at one end of the Avenue of the Dead can travel hundreds of feet, hinting at designs meant to amplify voices during ceremonies. Every element feels intentional, from the mineral-laden pyramids to the star-chasing streets, as if the builders were blending physics and spirituality into a single language. What's most unsettling is how little we know about who designed this. Unlike the Maya or Aztecs, Teotihuacan's creators left no decipherable texts or royal tombs, just a city so advanced it inspired later civilizations to claim it as their own. Modern attempts to recreate its alignments using period tools show it would have required generations of observation, a living archive of sky knowledge passed down through centuries. Perhaps that's the real feat here, not just the stones, but the minds that arranged them, turning an entire metropolis into a clockwork universe where every street, every pyramid whispered secrets we're still straining to hear. Carved into the Delhi iron pillar's weathered surface, 6 lines of ancient Sanskrit tell a story of conquest and ego, proof that even the most advanced engineering feats couldn't escape the human urge to brag. The inscription, dated to around 400 CE, declares the pillar was erected to celebrate King Chandragupta II's military triumphs. boasting that his glory burned as fiercely as the sun across conquered lands. It's a poetic flex typical of royal monuments, but here's the twist. While the king's name faded from memory, the pillar itself became immortal, not through words but through chemistry. The real magic lies in what the inscription doesn't mention: the pillar's uncanny resistance to rust. Modern metallurgists have spent decades analyzing its composition, discovering a deliberate recipe of high phosphorus iron mixed with slag particles. This wasn't accidental. Ancient Indian smiths seem to have understood that phosphorus, when carefully balanced, reacts with oxygen to form a thin, protective barrier against corrosion. The irony is delicious. A king's vanity project meant to tout short-term victories inadvertently became a 2,000-year advertisement for the region's scientific prowess. What's even more fascinating is the disconnect between the inscription's bravado and the pillar's quiet resilience. The text speaks of battles and power, but the metal whispers of patience and precision. Think of it like this: while Chandragupta's enemies crumbled into dust, his pillar stood unyielding, not because of his military might, but because of some anonymous blacksmith's genius. No epic poems were written about that craftsman, no temples built in his honor, just this silent, rust-proof monument to overlooked brilliance. Now compare this to modern material science. Today, we spend billions developing stainless steel and anti-corrosion coatings, yet this 4th century relic outperforms them all without a single lab or textbook. Recent studies even suggest the pillar's microstructure could inspire new alloys for seawater pipelines or spacecraft. That's the ultimate plot twist. A king's war memorial might one day help colonize Mars. The inscription wanted us to remember Chandragupta, but history had other plans. The real legacy here isn't the ruler, it's the science hiding in plain sight, waiting for us to catch up. The Pantheon's dome isn't just an architectural marvel, it's a 2,000-year-old middle finger to gravity. Even today, this unreinforced concrete giant remains the largest of its kind on Earth, spanning 142 feet without a single steel beam or modern support. Step inside and your eyes instinctively dart upward to the oculus, that dramatic 30-foot opening at the crown, where sunlight streams in like a spotlight from the heavens. But here's what's truly wild: that hole isn't a design flaw. It's the reason the dome hasn't collapsed under its own weight. Ancient Roman engineers understood something modern architects often forget. Sometimes the secret to strength is knowing where to leave gaps. The oculus acts as a pressure valve, redistributing the dome's immense load evenly across its curvature. Without it, the concrete would crack under tension. But with that central void, the force flows outward in perfect harmony, like ripples circling away from a dropped stone. Then there's the concrete itself, no ordinary mix. The Romans tweaked the recipe as the dome rose, embedding heavier volcanic rock at the base and switching to lighter pumice near the top. This graded aggregate distribution created a self-reinforcing structure, thinning as it climbed to reduce weight without sacrificing stability. Modern engineers still can't replicate this feat exactly. We've built bigger domes, sure, but all rely on steel reinforcements, a crutch the Pantheon's builders never needed. Even more baffling, the dome's precise geometry. Its height matches its diameter, forming a perfect sphere that could nestle snugly inside the rotunda. This wasn't just aesthetic, it optimized stress distribution, turning the entire structure into a self-supporting shell. And let's talk about that concrete's longevity. While modern equivalents crumble in decades, the Pantheon's mix blended with volcanic ash, just like their seawater-resistant harbors, has endured earthquakes, invasions, and 2 millennia of weather. The real tragedy: this knowledge vanished with Rome's fall. Medieval architects attempting similar spans watched their domes collapse until Brunelleschi reinvented the wheel in the 15th century, and even his Florence cathedral dome used inner and outer shells with hidden support chains. Standing beneath the Pantheon's dome today, you're not just looking at ancient engineering. You're witnessing a high watermark of material science, a masterpiece so advanced it took humanity over 1,000 years to catch up. And maybe, just maybe, we still haven't. While medieval Europeans were dumping chamber pots into the streets, the Minoans were enjoying flushing toilets 2,000 years before the Common Era. The Palace of Knossos in Crete boasted a plumbing system so advanced it wouldn't be matched until the 19th century. Picture this: terracotta pipes with precisely fitted joints, designed to slope at just the right angle for optimal water flow, channeling fresh water into palaces and flushing waste out through an underground sewage network. This wasn't just functional, it was elegant engineering, a testament to a civilization that valued hygiene as much as art or architecture. The real genius lay in the details. Those pipes weren't just hollow tubes, they were carefully tapered with narrower outlets that increased water pressure to prevent clogs. Some sections even had sedimentation tanks to filter debris, a feature modern septic systems still use. And then there were the toilets themselves, stone seats with wooden lids, connected to a drainage system that whisked waste away using gravity and rainwater. Archaeologists found traces of these systems intact, proving they weren't just theoretical. They were daily luxuries for Minoan elites. Now, fast forward to medieval Europe, where the Romans' aqueducts lay in ruins and the concept of sanitation had devolved into open gutters running down city streets. London's infamous Fleet Street didn't just smell like a cesspool, it was one with waste piling so high it sometimes blocked doorways. While Knossos had flush toilets in 2000 BC, 14th century Parisians were still tossing their waste out windows, shouting, "Gardes l'eau." The origin of the term loo, the regression wasn't just technological, it was a public health disaster contributing to plagues like the Black Death. What made the Minoans different? Their culture revolved around water's sacred and practical roles. Frescoes show elaborate rituals involving libations and baths, suggesting cleanliness was tied to spirituality. But there's also evidence of pragmatic problem-solving. Cisterns stored rainfall during dry seasons, and pipes were deliberately buried to protect them from earthquakes. This wasn't just engineering, it was a holistic understanding of nature's rhythms. The haunting question isn't why the Minoans built this system, it's why their knowledge vanished. When their civilization collapsed around 1450 BC, possibly due to volcanic eruptions or invasions, their plumbing secrets were buried under rubble and myth. Even the Greeks who later occupied Crete didn't replicate it, leaving Europe to rediscover sanitation the hard way centuries later. Today, standing in the ruins of Knossos, you can still see those terracotta pipes, a silent rebuke to the idea that progress is linear. Sometimes brilliance flares up then flickers out, waiting for the world to catch up. Deep in the jungles of Costa Rica, a cluster of near-perfect stone spheres has puzzled archaeologists for nearly a century. Ranging from the size of a bowling ball to massive orbs over 8 feet in diameter, weighing as much as 2 adult elephants, these granite spheres are so precisely round that modern measurements show deviations of less than 2 millimeters. Carved by the Decay culture between 600 and 1500 CE, they raise one glaring question. How did a pre-Columbian society without metal tools or written language achieve geometric perfection on this scale? Theories about their purpose are as varied as their sizes. Some researchers believe they functioned as astronomical markers, arranged in patterns mirroring constellations or solstice alignments. Excavations at key sites like Finca 6 revealed spheres positioned in straight lines or triangles, hinting at celestial significance. Others argue they were territorial markers for elite settlements, their imposing presence signaling power and status. Indigenous oral traditions suggest a more mystical role, that the spheres were shot put by the gods, hurled from sacred mountains to land where the deities willed. Whatever their purpose, their craftsmanship is undeniable. How did the Decays pull this off? Archaeologists think the process began by heating granite boulders with fire, then rapidly cooling them with water to fracture the rock. Stone tools like chisels and hammerstones were likely used to rough out the shape, followed by meticulous pecking and grinding with abrasives like sand. But achieving true sphericity required more than patience. It demanded an intuitive grasp of geometry. Some spheres show scoring lines, suggesting artisans may have used string or wooden compasses to check curvature, adjusting imperfections until symmetry was achieved. The real mystery isn't just how they were made, but why so many were moved. Many spheres were found miles from quarries, meaning the decay transported multi-ton granite orbs through dense rainforest without wheels or pack animals. The most plausible theory involves log rollers and rope, with teams leveraging inclines to navigate rough terrain. Yet even this would have required staggering coordination and a motive compelling enough to justify the effort. Modern threats now overshadow ancient enigmas. Many spheres were dynamited in the 1930s by treasure hunters convinced they held gold, while others were looted for private gardens. Today, less than half remain in their original locations, with UNESCO scrambling to protect those that survive. Standing beside one of these orbs, you're struck by their silent defiance, a civilization's legacy reduced to near-perfect stone, daring us to unravel the hands and minds that shaped them. Buried within the cliffs of Maharashtra, India, the Ajanta and Ellora caves present a paradox. How do you carve a temple from the top down? Unlike traditional construction, where builders stack materials upward, these 34 rock-cut sanctuaries were sculpted in reverse, starting at the ceiling and working downward. Imagine teams of artisans dangling from ropes, chiseling delicate floral motifs and towering Buddha statues directly into volcanic basalt, all while trusting their calculations wouldn't leave a single critical pillar too thin or a ceiling too weak. This wasn't just artistry, it was architectural acrobatics on a scale that defies modern logic. Light played as much a role as chisels in these caverns. Without electricity or mirrors, designers engineered precise openings to harness sunlight, angling shafts so dawn rays would illuminate a statue's face or midday beams would cascade across a frescoed wall. The Kailasa temple at Ellora takes this further. Its central shrine, carved to resemble Mount Kailash, features a courtyard designed so equinox sunlight strikes the deity's forehead at noon. Such precision suggests an intimate understanding of solar geometry, achieved centuries before the telescope's invention. The tools were deceptively simple: iron chisels, wooden wedges, and hammers. Yet the workflow was anything but. Artists first smoothed the rock face, then sketched outlines with red ochre before making initial cuts. As they deepened the cavities, they left guide pillars standing to prevent collapses, only removing them once surrounding structures were stable. Some caves span multiple stories, with staircases and balconies all carved from a single piece of stone, meaning a single misjudgment could ruin months of work. What's most striking isn't the scale, though, it's the diversity. Ajanta's earlier caves, 2nd century BCE, burst with frescoes depicting Jataka tales, their pigments mixed with plant gums to outlast centuries. Ellora's later additions, 6th to 10th century CE, showcase Hinduism, Buddhism, and Jainism side by side, a testament to India's pluralistic spirit. In Cave 16, the Kailasa temple's sheer audacity stuns workers removed over 2 million tons of rock to free this monolithic structure from the hillside, a project that would have required 200 laborers working daily for 2 decades. Modern engineers still debate how they managed drainage, preventing water accumulation in windowless chambers. The answer lies in hidden slopes and channels, redirecting moisture before it could erode delicate carvings. Even monsoon rains were accounted for, with drip lines carved above entrances to shield murals from splashes. This level of foresight hints at a tradition honed over generations, where each cave was a lesson passed to the next team. Standing in these dim passages today, you're surrounded by whispers of a forgotten workflow. The absence of scaffolding holes or debris piles suggests a near-surgical precision, with rubble likely repurposed for nearby settlements. Some walls bear unfinished panels, snapshots of techniques frozen in time, showing how rough shapes were refined into flowing drapery or serene expressions. These caves don't just challenge our assumptions about ancient tools, they redefine what patience and collective vision can achieve when stone becomes a canvas and a mountain a sanctuary. Beneath the bustling streets of Rome lies a hidden masterpiece of hydraulic engineering. The Claudius Aqueduct, an 11-mile tunnel carved through solid rock with nothing but hand tools and human determination. What makes this first-century marvel truly astonishing isn't just its length, but its impossible precision. To keep water flowing at a steady pace from the Anio River to the heart of the empire, Roman engineers maintained a gradient of just 1 foot drop for every 3,000 feet of distance, a slope so slight you'd barely feel it walking downhill. That's like tilting a football field by less than half an inch and keeping it perfectly even from end to end. No pumps, no valves, just gravity and geometry working in flawless harmony. The logistics boggle the mind. Teams of laborers, likely slaves and skilled diggers, chiseled through volcanic tuff and limestone using picks and chisels, working in oppressive darkness with only oil lamps for light. Ventilation shafts were spaced at strategic intervals, some plunging over 100 feet straight up to the surface, ensuring workers didn't suffocate from stale air or the smoke of their own torches. But here's where Roman ingenuity really shines. They didn't just dig blindly. Surviving surveying tools like the corybates, a wooden level filled with water, allowed them to check the tunnel's slope with astonishing accuracy. If they veered off course even by a fraction, the entire system would fail, water would stagnate or overflow. Yet somehow, over 11 miles of unpredictable geology, they nailed it. Modern engineers have calculated that maintaining this 1 to 3,000 gradient required tolerances tighter than many contemporary pipelines. For comparison, today's sewer systems often use slopes 10 times steeper just to account for margin of error. The Romans had no laser levels, no GPS, just knotted ropes, plumb bobs, and an unwavering grasp of mathematics passed down from Greek scholars, and they didn't stop at straight lines. The aqueduct's path twists to avoid unstable rock, dips beneath valleys, and even incorporates sedimentation tanks to filter debris, all while preserving that critical flow rate. The real kicker, this wasn't a one-off experiment. The Claudius Aqueduct was one of 11 major systems feeding Rome, part of a network delivering over 300 million gallons of water daily, more per capita than many modern cities. Its tunnels were so well built that sections remain intact today, buried but functional, a silent testament to a civilization that viewed water not just as a resource but as a sacred trust. Standing in those damp, echoing passages, you can almost hear the echoes of picks striking stone, a rhythm as precise as the water that once flowed there, an ancient algorithm written in rock and motion. Beneath the quiet streets of modern Malta lies a realm where sound takes on supernatural qualities, the hypogeum of Hal Saflieni. Carved from solid limestone over 5,000 years ago, this 3-level labyrinth isn't just one of the world's oldest underground temples, it's an acoustic anomaly that defies explanation. Step into the so-called oracle chamber, and your whisper against one wall can be heard clearly 50 feet away, while deeper tones resonate through the stone like the hum of some ancient machine. The effect isn't accidental. Every curve, every niche seems calculated to manipulate sound in ways we're only beginning to understand. What separates the hypogeum from other Neolithic sites is its deliberate sonic design. Researchers using frequency sweeps discovered that certain chambers amplify voices at exactly 110 Hz, a pitch known to alter brain activity, often triggering trance-like states in listeners. Modern experiments show this frequency stimulates the right hemisphere of the brain, the side associated with creativity and spiritual experiences. Coincidence? Unlikely. The builders likely discovered this through trial and error, shaping the rock to enhance rituals where sound wasn't just heard but felt, vibrating through bones and bedrock alike. The techniques behind this feat are as mysterious as their purpose. Without metal tools, Neolithic workers excavated over 2,000 square feet of space, using stone picks and antler shovels to carve spiral motifs and false windows identical to above-ground temples. But the acoustic precision suggests something more, perhaps an early understanding of waveform physics, where angles and surfaces were tuned like instruments. Some chambers even feature sound portals, narrow openings that filter specific frequencies between rooms, creating eerie harmonies when chants pass through them. Then there's the haunting possibility of infrasound frequencies below human hearing that can induce unease or visions. The hypogeum's deepest chambers produce these naturally from air currents, leading some to speculate the site was an intentional portal, using sound to blur the line between worlds. Local folklore speaks of sleeping priestesses whose murmurs still echo in the dark, while modern visitors report unexplained voices and pressure changes, even when alone underground. Most unsettling of all, this knowledge vanished with the builders. By the time the hypogeum was rediscovered in 1902, its original purpose had been erased by time, leaving only the walls themselves as clues. Today, access is tightly controlled not just to preserve the fragile paintings of red ochre spirals, but to protect visitors from the disorienting effects of a space engineered to change those who enter. Standing in that silence, you're left with a chilling thought. Maybe some ancient technologies weren't about moving stones but manipulating minds, and the hypogeum's architects mastered both. Off the coast of modern-day Gujarat, beneath the waves of the Arabian Sea, marine archaeologists have uncovered a city so ancient it rewrites our understanding of Indian civilization. The submerged ruins of Dwarka, first discovered in 1983, stretch across nearly 5 miles of seabed, massive stone walls, intricate drainage systems, and even a dockyard that could have once berthed hundreds of ships. What makes these ruins extraordinary isn't just their scale, but their eerie alignment with Hindu texts like the Mahabharata, which describe Krishna's celestial city as having golden spires that sank beneath the ocean after his death. For centuries, scholars dismissed these accounts as myth until carbon dating placed the structures at over 9,000 years old, predating the oldest known cities of Mesopotamia by millennia. Diving into these waters is like entering a time capsule. The layout mirrors descriptions from ancient scriptures with distinct sectors for trade, worship, and governance. Stone anchors weighing hundreds of pounds suggest a bustling maritime culture, while recovered artifacts, pottery shards, beads, and even a carved seal depicting a 3-headed animal hint at connections to the Indus Valley civilization. But here's the twist: the ruins aren't just old, they're drowned in a way that defies simple sea level rise. Studies reveal evidence of sudden subsidence, fissures in walls snapped cleanly, as if the land dropped violently. Geological cores from the area show layers of marine sediment abruptly covering urban debris, pointing to a catastrophic event around 1500 BC, possibly a massive tsunami or tectonic shift. The implications are seismic. If Dwarka's dating holds, it means advanced urban planning existed millennia earlier than mainstream history acknowledges. The city's grid-like streets and stormwater drains rival those of Mohenjo-Daro, yet they're thousands of years older. Even more provocative are the claims of some researchers, who argue Dwarka's submerged structures display machining marks, straight, grooved cuts that resemble tooling from advanced technology. Mainstream archaeology disputes this, attributing the precision to natural erosion or later rebuilding. But the debate forces a humbling question: how much of our past lies hidden beneath the waves, forgotten because we assumed our ancestors couldn't have achieved such feats? Local fishermen still whisper about Krishna's lost city, describing odd shadows under the water at low tide. Modern sonar mapping has only deepened the mystery, revealing concentric circular structures that match descriptions of Dwarka's defensive moats. The real challenge now isn't just uncovering more ruins, it's rethinking the timeline of human innovation. Because if a city this sophisticated existed 9,000 years ago, what else might we have missed? Standing on the shore today, watching the tide roll over what was once a metropolis, you're left with a haunting realization. Sometimes the boundary between myth and history isn't a line, it's a coastline shifting with every wave of discovery. High in Peru's sacred valley, the ruins of Ollantaytambo cling to the mountainside like a half-finished puzzle, one where the pieces weigh 50 tons each. These massive red granite blocks, some as tall as a two-story building, were hauled across rivers and up steep slopes, only to be abandoned mid-construction by the Inca. What's baffling isn't just their size, but the unanswered question etched into their surfaces. How were they supposed to reach the temple's upper tiers? The Incas left no cranes, no pulleys, just these stranded giants and a trail of theories as varied as they are contentious. Start with the logistics of moving these monoliths. The quarries where the stone was extracted lie 6 miles away across the roaring Urubamba River. Researchers believe the Incas used a combination of ramps, sledges, and sheer manpower, possibly lubricating the path with clay to reduce friction. But the real mystery begins at the site itself, where the blocks were meant to ascend terraces rising hundreds of feet. Some archaeologists point to earthen ramps, long since eroded, while others speculate about lever systems or even counterweights made of smaller stones. Then there's the strange detail that sets Ollantaytambo apart. Faint, glass-like patches on some surfaces, as if the granite had been briefly liquefied. This phenomenon, called vitrification, has sparked fierce debate. Traditional scholars argue these glossy patches are natural weathering or the result of ceremonial fires. But a vocal minority suggests something more radical, that the Incas might have used lenses or concentrated sunlight to soften the stone, allowing for precise shaping. Experiments with modern solar arrays show it's technically possible to melt granite at extreme temperatures, though replicating it at this scale with 15th century technology stretches credibility. Even stranger, similar vitrified stonework appears in other ancient sites, from Scotland to Egypt, hinting at either a widespread lost technique or an odd geological coincidence. The site's unfinished state adds another layer of intrigue. Some blocks are partially carved, their edges still bearing the chisel marks of interrupted labor. Others lie in precise rows, as if waiting for a signal to rise. Historians suspect construction halted abruptly during the Spanish conquest, when the Inca shifted focus to defense. But what if the project was always impractical? The quarried blocks grow larger as you ascend the site, suggesting each new tier demanded exponentially more effort. Were the builders overreaching, or did they possess knowledge we've yet to uncover? Standing among these stones, you're struck by their silent defiance. Unlike polished monuments, Ollantaytambo's megaliths are raw, frozen mid-journey. They don't boast of triumphs, they whisper of ambitions interrupted, of a plan so grand even the Inca couldn't fully realize it. And that's the real lesson here. Sometimes the most revealing artifacts aren't the finished masterpieces, but the unfinished attempts, daring us to imagine what might have been. In a dimly lit museum in Baghdad sits an unassuming clay jar, barely 6 inches tall, a relic that might just rewrite the history of electricity. Found in 1936 near the ancient city of Ctesiphon, this 2,000-year-old artifact consists of a copper cylinder, an iron rod, and traces of an acidic substance like vinegar or wine. At first glance, it looks like a simple storage vessel, but the arrangement of its components has sparked a century of debate. Could this be the world's oldest known battery? The theory isn't as far-fetched as it sounds. When filled with an electrolyte solution, the Baghdad battery could produce around 1 volt of electricity, enough to give you a faint tingle but far from lighting up a room. So what practical use would that have served? Some researchers point to ancient goldsmithing techniques. Artifacts from Mesopotamia show objects plated with gold so thin and even that it's hard to explain without electroplating. Imagine dipping a silver statue into a gold solution, then using this rudimentary cell to bond the metals. Experiments replicating the jar's design have proven it's possible, though skeptics argue there's no direct evidence the ancients understood the process. Alternative explanations lean toward the mundane. The jar could have been a storage container for sacred scrolls, with the iron and copper acting as protective elements. Others suggest it was part of a medical device, delivering mild shocks for pain relief, a practice documented in ancient Greek and Roman texts. The absence of wires or connectors complicates the battery theory, but here's the twist. Acidic residue found inside multiple jars hints at repeated use with liquids, not dry storage. What's most fascinating isn't whether it worked, but the broader implication that multiple civilizations might have stumbled upon electrical principles long before Galvani and Volta gave them names. The Egyptians described shocking fish in the Nile, while Roman naturalists wrote about metals that tingled when touched together. Could these moments have been more than curiosities? The Baghdad battery, whether a fluke or intentional, forces us to reconsider the boundaries of ancient innovation. It's a humbling reminder that history's most revolutionary discoveries might not always leave a paper trail, just a quiet, charged spark waiting to be rediscovered. Off the coast of Japan's Yonaguni Island, the ocean floor hides a structure so perplexing it sparked decades of fierce debate among geologists and archaeologists. The Yonaguni Monument, discovered in 1986 by a local diver, resembles a massive stepped pyramid rising 80 feet from the seabed, complete with near-perfect 90-degree angles, flat terraces, and what look like staircases carved into its sides. At first glance, it's hard to dismiss the resemblance to ancient ziggurats or ceremonial platforms. But here's the catch: the monument is submerged under 16 feet of water, a depth that suggests it was last above sea level at least 10,000 years ago, long before conventional history says humans were capable of such construction. What makes Yonaguni so controversial are those uncanny features that seem too precise for nature alone. The main terrace is a flat platform the size of a basketball court, bordered by sharp, straight edges that meet at clean right angles. Nearby, two towering pillars appear, placed deliberately as if framing an entrance, while a 5-meter-wide tunnel cuts through the base with unnerving symmetry. Even the rock faces show clusters of evenly spaced holes, reminiscent of post holes used in ancient masonry. Proponents of the artificial origin theory, like researcher Masaki Kimura, argue these elements couldn't be random. They point to tool marks and carvings resembling Qaeda script, an ancient writing system used in the region. Skeptics counter that nature is perfectly capable of creating such geometry. Sandstone, the rock composing Yonaguni, naturally fractures along straight lines due to tectonic stress. Ocean currents could have eroded softer layers, leaving behind stepped formations. Some geologists compare the site to the Giant's Causeway in Ireland, where volcanic activity produced strikingly geometric columns without human intervention. Even the staircase might be a series of wave-cut notches shaped by millennia of tides, yet there are details that muddy the waters. Nearby, divers have found what looks like a carved human face and a turtle-shaped altar. Artifacts that, if verified, would tilt the scales toward human craftsmanship. Then there's the location itself. Yonaguni sits at the heart of the Pacific Ring of Fire, a region prone to catastrophic earthquakes and rapid subsidence. Could an advanced prehistoric civilization have built here, only to vanish beneath the waves in a single catastrophic event? Indigenous Ryukyuan legends speak of drowned cities and gods who sank beneath the sea, eerie echoes of Plato's Atlantis myth. The debate is far from settled, but one thing's clear: whether natural or human-made, the Yonaguni Monument forces us to reconsider the timeline of Pacific cultures. If artificial, it hints at a sophisticated society thriving millennia earlier than we thought. If natural, it's a testament to how powerfully geology can mimic human design. For now, the monument remains a riddle wrapped in seawater and shadows, an enigma that reminds us how much of our planet's history still lies hidden, waiting to surface. Rising from the southern African savanna, the stone walls of Great Zimbabwe form a silent rebuttal to centuries of colonial arrogance. This sprawling city, constructed between the 11th and 15th centuries, features dry stone masonry so precise that even today, after 700 years of exposure to wind and rain, many sections stand perfectly intact without a drop of mortar. The technique is deceptively simple yet staggeringly effective granite blocks painstakingly shaped to fit together like a three-dimensional puzzle, each stone's weight and angle distributing pressure evenly across the structure. But what's truly revolutionary isn't just the engineering. It's the story these walls tell about a civilization that European colonizers refused to believe could exist. When Portuguese traders first glimpsed the ruins in the 16th century, they assumed such sophistication couldn't be African. Later, British colonizers doubled down on this racist myth, insisting the site must have been built by Phoenicians, Arabs, or even the biblical Queen of Sheba. Archaeologists in the 19th century went so far as to dynamite parts of the ruins, hunting for proof of foreign builders. The truth revealed by modern research is far more powerful. Chemical analysis shows the granite was quarried just miles away, and artifacts recovered from the site, including pottery, iron tools, and gold ornaments, bear distinctly Shona designs, linking the city to descendants who still live in the region today. The scale of labor involved is mind-boggling. The Great Enclosure, the site's most iconic structure, contains nearly 1 million stones, all cut and stacked by hand. The curved outer wall towers 36 feet high in places, with a circumference longer than 2 football fields. Yet the real brilliance lies in the details. Unlike European mortar-dependent constructions, these dry stone walls flex slightly during earthquakes or heavy rains, preventing catastrophic collapse. The builders even incorporated natural drainage channels, sloping surfaces to redirect rainwater and protect the foundations, a feature many modern architects overlook. Walking through the ruins today, you're struck by the city's purposeful design. The hill complex, likely a royal residence, commands strategic views of the surrounding plains, while the valley ruins suggest a thriving artisan class producing gold and ivory, goods for trade networks stretching to China and the Middle East. This wasn't just a settlement, it was the heart of a kingdom controlling one of the richest gold trading economies of its time. The walls weren't merely functional, they were a declaration of power, a visual manifesto meant to awe visitors and reinforce the ruler's divine authority. The greatest injustice isn't that these techniques were ignored, it's that they were actively suppressed. Colonial regimes confiscated artifacts, burned records, and taught generations that Africa had no history worth studying. Yet the stones refused to be silenced. Today, Zimbabwe's national flag bears an image of the soapstone birds found at the site, reclaiming a narrative that was nearly erased. The lesson here isn't just about ancient engineering, it's about who gets to write history, and how the truth, like those unmortared walls, endures long after empires crumble. Standing in the shadow of these ruins, you're not just seeing a marvel of construction, you're witnessing resilience carved in stone. Deep within the Temple of Hathor at Dendera, a series of carvings have ignited a debate that blurs the line between ancient symbolism and potential technological marvel. One relief in particular stops visitors in their tracks, a strange, bulb-like object cradling a snake, connected to what appears to be a cable leading to a box held by a priest-like figure. To the untrained eye, it looks uncannily like an electric light bulb, complete with filaments and a socket. Could this be evidence that the ancient Egyptians harnessed electricity, or is there a more grounded explanation hidden in the sands of time? Mainstream Egyptologists dismiss the light bulb interpretation as a modern misreading of religious iconography. They argue the snake represents the cosmic serpent Harsomptus emerging from a lotus flower, a symbol of creation and rebirth central to Egyptian mythology. The so-called cable is likely a stylized lotus stem, while the box resembles a jed pillar, an emblem of stability. Similar motifs appear across other temple reliefs, always tied to spiritual narratives rather than technical diagrams. The flickering torches and polished metal mirrors found in tombs, they point out, were the extent of Egyptian lighting technology, yet the fringe theory persists, fueled by tantalizing anomalies. The dendera bulbs are depicted in dark underground chambers where torches would have left soot stains, yet no such marks exist. Experiments show that replicas of the described objects, filled with argon or another inert gas, could theoretically produce a dim glow when electrified. Even more intriguing are the so-called Baghdad battery artifacts found in Mesopotamia terracotta, pots with copper and iron components that, when filled with acidic liquids, generate a small voltage. Could these technologies have been connected across ancient trade routes? The truth may lie somewhere between both camps. While no physical evidence of Egyptian electrical devices has been found, the precision of their craftsmanship raises questions. The temple's architects mastered celestial alignments and acoustic engineering. Why not energy manipulation? Perhaps the relief isn't a literal light bulb, but a metaphorical representation of sacred knowledge, using imagery that feels eerily familiar to modern eyes. After all, the line between divine illumination and electric light might have been thinner for the ancients than we assume. Standing before the dendera carvings, you're faced with a choice. Dismiss them as mere art or entertain the possibility that our ancestors' understanding of the natural world was far more nuanced than we've credited. Either way, the reliefs challenge us to reconsider what advanced truly means across the span of human history. Sometimes the most illuminating discoveries aren't about finding answers, but learning to ask better questions. The ruins of Puma Punku don't just defy expectations, they seem to mock them. Scattered across Bolivia's high-altitude plains, these jagged stone fragments include blocks carved into perfect H shapes, their edges so sharp they look like they were sliced by a laser. The material alone is a puzzle. Andesite, a volcanic rock ranking 6 on the Mohs hardness scale, tougher than steel. Yet every surface gleams with a smoothness that would challenge modern diamond-tipped tools. So how did a culture without metalworking achieve this precision over 1,000 years ago? The answer might lie in a combination of forgotten techniques and painstaking patience. Start with the tools. Archaeologists believe the builders relied on harder stones like quartzite to grind and polish the andesite, a process that would have required countless hours of repetitive motion. But the real mystery isn't just the shaping, it's the consistency. Identical H-blocks interlock like pieces of a grand geometric puzzle, suggesting standardized templates or advanced measuring systems. Some grooves feature drill holes so uniform they appear machined, while flat surfaces show no tool marks at all, as if sanded by some unknown method. One theory points to abrasive pastes made from crushed quartz and water, applied with leather or reed pads to achieve that mirror-like finish. Then there's the logistics. The nearest andesite quarry lies over 10 miles away, meaning these multi-ton blocks were transported across rugged terrain without wheels or pack animals. Local Aymara legends speak of giants who built Puma Punku in a single night, while fringe researchers speculate about sonic levitation or lost alloys. But the most compelling clue might be the site's own destruction. Many blocks are shattered as if by immense force, their edges cleanly snapped, a pattern some geologists attribute to a catastrophic flood or seismic event. Could the builders' secrets have been buried under the same disaster that shattered their work? What's undeniable is the craftsmanship's ambition. The precision isn't just aesthetic, it's structural. Blocks fit together so tightly that, like the Inca walls of Sacsayhuaman, They've withstood centuries of earthquakes without mortar. Modern engineers struggle to replicate these joins even with computer-guided cutting. Standing among these ruins, you're left with a humbling thought. Perhaps the real feat wasn't just the cuts, but the vision behind them, a culture that saw stone not as a barrier, but as a canvas waiting to be unlocked. Buried beneath the windswept hills of southeastern Turkey, the towering limestone pillars of Göbekli Tepe rewrite the entire timeline of human civilization. These massive T-shaped monoliths, some weighing over 16 tons and standing 16 feet tall, were carved and erected around 12,000 years ago, 7 millennia before Stonehenge and 5,000 years before the first pyramids. What makes this site truly revolutionary isn't just its age, but the fact it was built by hunter-gatherers, a people we've long assumed were too preoccupied with survival to undertake such colossal projects. The logistics alone boggle the mind. Without metal tools, wheels, or domesticated animals, these prehistoric builders quarried limestone from local bedrock using nothing but stone chisels and sheer muscle. The pillars weren't just hacked roughly from the earth, they were shaped with eerie precision. Their surfaces smoothed and adorned with intricate bas-reliefs of foxes, scorpions, and vultures, their edges so sharp they could have been cut yesterday. Then came the real challenge, transporting them. The nearest quarry sits nearly a quarter mile from the site, meaning teams of workers somehow dragged these multi-ton slabs uphill without the aid of carts or pulleys. Experiments suggest they might have used wooden sledges atop rollers made of tree trunks, leveraging inclines and manpower in a grueling ballet of coordination. But the bigger mystery lies in the why. Göbekli Tepe predates agriculture by thousands of years, upending the long-held belief that monumental architecture only emerged after humans settled into farming communities. Its circular enclosures, each anchored by two central pillars surrounded by smaller stones, suggest a ritual purpose, perhaps a gathering place for seasonal ceremonies or a proto-temple to honor animal spirits. The carvings themselves offer tantalizing clues. Vultures, often associated with death in early Anatolian cultures, hint at funerary rites, while the recurring fox motifs might symbolize cunning or transformation. What's truly unsettling is the site's deliberate burial. Around 8000 BCE, someone methodically filled in the entire complex with tons of soil and rubble, preserving it like a time capsule until its rediscovery in the 1990s. Was this an act of reverence, hiding sacred ground from intruders, or a practical decision by a society shifting toward farming, leaving their nomadic past behind? The answer might rewrite our understanding of cultural evolution, proving that the urge to build, to create meaning in stone, runs deeper in human nature than we ever imagined. Standing among these pillars, you're struck by their silent defiance. They don't just predate history, they challenge it, forcing us to reconsider what primitive really means. Maybe civilization didn't evolve in a straight line from survival to art. Maybe, just maybe, the art came first and everything else followed. Long before the age of computers and industrial robotics, a genius in 1st century Alexandria was building machines that seemed to defy the limits of his era. Hero of Alexandria, mathematician, engineer, and inventor, created a series of steam-powered automata so advanced they wouldn't be matched for over 1,000 years. Imagine walking up to a grand temple, and as you approach, the doors swing open on their own, as if guided by invisible hands. This wasn't magic, it was engineering. Hero's design used a series of pistons, weights, and a carefully controlled fire to generate steam pressure, triggering a mechanism that made the doors appear to move by divine will. But that was just the beginning. Among Hero's inventions was a fully automated theater, where tiny mechanical figures performed an entire play. Ships sailed, gods thundered, and puppets reenacted myths, all powered by a sophisticated system of ropes, drums, and rotating cylinders. Think of it as the ancient ancestor of a cuckoo clock, but infinitely more complex. His eolipile, or steam-powered sphere, demonstrated the principles of jet propulsion centuries before the concept was formally understood. When heated, water inside the metal sphere turned to steam, escaping through angled tubes and causing the entire device to spin at high velocity. It was the world's first steam engine, though its potential as a power source wouldn't be realized for centuries. What makes these inventions even more astonishing is the context. Hero lived in a world without precision machining, electricity, or mass production. Every gear, every piston, every moving part had to be crafted by hand, their tolerances fine-tuned through trial and error. His works weren't just novelties, they were testaments to an understanding of physics far beyond what textbooks suggest ancient engineers possessed. And yet, for all their brilliance, these machines were largely forgotten after Rome's decline. Why? Part of the answer lies in the priorities of the time. Hero's automata were seen as entertainment, not practical tools, so when resources grew scarce, the knowledge to maintain them faded. The real tragedy is how close the ancient world came to an industrial revolution. Had Hero's steam engine been adapted for wider use powering mills, ships, or machinery, history might have unfolded differently. Instead, his manuscripts gathered dust in libraries until the Renaissance, when engineers like Da Vinci rediscovered them with awe. Today, we recognize Hero as a pioneer of robotics, a man whose ideas were centuries ahead of their time. His legacy is a powerful reminder: progress isn't guaranteed. Sometimes the brightest sparks of innovation flicker out, waiting for the right moment to reignite. Imagine living in 2nd century China, where earthquakes could strike without warning, toppling homes and swallowing villages whole. Then a brilliant astronomer and inventor named Zhang Heng unveiled a device that seemed to defy nature itself, a towering bronze vessel adorned with 8 sinuous dragons, each clutching a metal ball above the open mouth of a corresponding bronze toad. When the earth trembled, one of those dragons would release its ball with a resonant clang, indicating not just that an earthquake had occurred, but precisely which direction it came from. This wasn't folklore or guesswork. It was the world's first seismoscope, engineered in 132 CE with a sophistication that still leaves scientists in awe. The mechanics behind Zhang Heng's invention remain hotly debated, largely because the original device was lost to history. What we know comes from ancient texts describing a hollow bronze urn with a central pendulum. When seismic waves disturbed the pendulum, it triggered a series of levers inside the vessel, causing only the dragon facing the earthquake's epicenter to release its ball. Modern reconstructions suggest the system could detect quakes hundreds of miles away, an astonishing feat for an era with no understanding of plate tectonics or Richter scales. In one legendary account, the device alerted the imperial court to an earthquake in a distant province days before messengers arrived with news of the devastation. Skeptics argue the seismoscope's accuracy might be overstated, pointing out that no surviving records detail its margin of error or sensitivity to minor tremors. Yet experiments with reconstructed models tell a different story. In 2005, a team of Chinese scientists built a replica using materials and techniques available in Zhang Heng's time. When subjected to simulated quakes, it correctly identified the direction of seismic waves 75% of the time, a success rate rivaling some early 20th century seismographs. The secret may lie in the pendulum's responsiveness to primary waves, the fast-moving but weak vibrations that precede an earthquake's more destructive shocks. What's truly remarkable isn't just the device's potential precision, but the thinking behind it. Zhang Heng operated without any modern understanding of seismology, yet he intuited that earthly tremors moved in directional waves, a concept formalized only 2 millennia later. His design also reflected a holistic worldview. The 8 dragons aligned with compass directions symbolized cosmic balance, while the toads represented the Earth's ability to swallow disaster. This wasn't just a tool, it was a philosophical statement blending art, science, and spirituality into a single instrument. Today, as engineers develop AI-powered earthquake alerts and satellite-based detection systems, Zhang Heng's seismoscope stands as a humbling reminder. Sometimes the past holds flashes of genius so bright they illuminate the future. Whether by luck or sheer brilliance, an inventor working 2,000 years ago grasped a truth about our restless planet and found a way to make the Earth itself speak. From the Great Pyramid's celestial precision to the Baghdad Battery's quiet spark, these 30 ancient marvels aren't just relics, they're revolutions carved in stone, cast in metal, and hidden beneath the waves. Each one shatters the myth that innovation is a straight line from primitive to advanced. The Romans poured concrete that outlasts our own, the Nazca mapped giants only the sky could see, and the Minoans flushed away waste while Europe wallowed in filth for millennia. These weren't accidents, they were calculated leaps by cultures who turned limitations into launch pads, proving genius isn't bound by era or toolset. But here's the haunting question lingering behind every perfectly fitted block and rust-free alloy. Were these feats outliers, flashes of brilliance in the dark, or fragments of a far grander tapestry of knowledge now lost? The Antikythera Mechanism suggests entire schools of engineering vanished without a trace. The submerged ruins of Dwarka hint at civilizations swallowed by rising seas. Even Hero of Alexandria's steam engines, technology ripe for an industrial revolution, gathered dust for centuries. What if these surviving wonders aren't exceptions, but glimpses of a norm we've forgotten? Maybe history isn't just the story of progress. Maybe it's also a cycle of discovery, loss, and rediscovery, a loop where every age has its blind spots. The Delhi Iron Pillar mocks our rusting bridges, while Teotihuacan's mica-lined pyramids whisper secrets we're still piecing together. These ancients didn't just build, they encoded their understanding in materials that would outlast parchment and language, leaving us breadcrumbs in stone and metal. So what's your take? Which of these feats left you awestruck? Was it the echoing oracle chambers of the Hypogeum, or the earthquake-defying walls of Sacsayhuaman? Drop your favorite in the comments and let's keep unraveling these puzzles together. And if you're craving more mysteries that bend the timeline of human achievement, hit subscribe, we're just scratching the surface. After all, the past isn't dead, it's waiting, full of voices we're only learning to hear.